In this lecture, I am going to cover a very important aspect about pointers and arrays. Actually, there is a very direct relationship between arrays and pointers. What happens is when we people declare an array, the space is allocated in the memory, and a pointer variable with the same name as the array name is automatically created in the memory, and that is assigned the base address of this array. By base address, I mean to say address of the very first element. For example, I have declared an array intr and I have given the size, suppose 5. So what will happen is I have assumed that the address of the very first element is 101, and as you know, one int value takes up 4 bytes in the memory. So the very next element will take up will use the address 105, the third element 109. There will be an interval of 4. Okay, the base address is 101. Now, because I have declared my array with the name arr, a pointer variable with the same name as the array name, that is arr, has been automatically created in the memory, and that has been assigned the base address, in this case which happens to be 101. In the second example, this is the same example, but I have assumed that this array amount happens to be of double data type. So suppose I have declared the array like double amount, within square brackets I have given the size, suppose 5. Now I have assumed the base address to be 9010. Because the array name is amount, when I will declare this array, a pointer variable with the same name as the array name, that means amount, would be automatically created in the memory, and that will be assigned the base address. In this case, I have assumed the base address to be 9010. It could be anything. I have just assumed that it is 9010. So this pointer variable with the name of the array would be containing this base address. So you should always keep this thing in mind, that an array name is pointed to base address. I repeat it, when you declare an array, what happens is a pointer variable with the same name as the array name is automatically created in the memory, and that is assigned the base address of this array. Now I am going to explain this with the help of an example. So this program is going to illustrate the fact that an array name is pointed to base address. Now this is the statement that you should always remember while working with arrays. An array name is pointed to base address. Okay, so here I have declared an array intr, and I have given it initialized it with 3 values. The size could be anything. Now the size is optional. As you know, when we initialize an array, the size is not compulsory to be given. So this is the value of arr0, 200 is the value of arr1, 900 is the value of arr2. So when I will print base, suppose I want to print the base address of this array, what I will do is I will write base address is equal to %u, and here I am going to print the name of the array, which happens to be arr. So what it will print is, it will print the address of the very first element, of course, which is called base address. Now we have learned about pointer arithmetic also. So through which we had learned that when we add 1 to any pointer variable, actually it adds the size of the data type. For example, in this case, address of second element, I want to print address of second element, which is arr1. So I am going to use this expression arr plus 1, because arr does not happen to be an ordinary variable. It is an array name, and array name is pointer to base address. So hence arr is a pointer variable. So when I would write arr plus 1, it will see what is the data type of arr. It is int. One int takes up 4 bytes in the memory. So that means arr plus 1 is going to add 4 to the current value of arr. Similarly, arr plus 2 will add 8, because it is arr plus 2. So 1 means 4 bytes, 2 means 8 bytes. So arr plus 2 will print the address of the third element. Arr plus 2 will print the address of the third element. And similarly, as you know, star is value at address operator. So when I am going to print like star arr, of course it will print value stored at address, which is contained in arr, and arr is containing address of the very first element. So it will print the first value. Arr plus 1, first evaluate arr plus 1. It is going to it is going to have the address of the second element, and star will print its address, and so on. So I'm going to execute this program, and you can see the results for yourself. Base address is this one. Now you can see address of the second element is going to be 4 bytes ahead, which is of course 4 number more than the base address, and address of the third element, that is add to, is again 4 bytes ahead. And that means here I have written R plus 1. I will again explain it to you. When I have written R plus 1, what was contained in R was 2293428. So when I wrote R plus 1, it has added 4 to the value of R. So it is 2293432. Similarly, when I wrote R plus 2, it added 8. So it became to the current value of R, which is 2293428. So the R plus 2 will yield the result 2293436. And when I have used star operator, which is in fact value at address operator, so star R will print the first value, star R plus 1 of course will print the second value, and star R plus 2 is going to print the third value, and so on. So this is in this program, see, I have printed the values and the addresses without using any loop. So it will become very cumbersome when we people have got an array with a considerable size. So I will show you a very simple technique. What you can do is you can simply apply a loop. So in this loop you can clearly see it for yourself. R plus 0 is going to print the address of the very first element, that is base address, and because star is value at address operator, it will print the first value. Again it will go up the loop, plus plus I will make the value of I as 1, condition is 2. So R plus 1 is going to print the address of the second element, and star R will print the value of the second element, and it will go on like this. So hence always remember, an array name is pointer to base address.